We're going to talk a little bit about hydraulics and electrical for the gale force and the A-force storm. Now, of course, the electrical, of course, it's as far as the electrical goes, both the sweeper and the chassis, they share the same batteries. The batteries are located here. And they are two batteries, and they both produce 12 volts of power. Now, in the back of the batteries, of course, we have the 80 amp breaker, which, of course, gives power to the console that is in the cab. At the same time, of course, it's powering up the chassis. So therefore, the direct charging for the batteries is the chassis alternator. In the front of the power module, we have all the electronics and the electrical for the auxiliary engine, which of course it is a Cummins engine. And the ECM, it is located in the front, and of course the power from the batteries to power up the auxiliary engine. The fuel pump is in the front as well. This one is actually producing the fuel required to run the auxiliary engine. The chassis, and of course the chassis, it could be a diesel and it could be also a gas. So therefore, if the chassis is a gas power chassis, we have an auxiliary fuel tank here with diesel to power up the Cummins engine. In the back of the cab, right here between the power module and the cab, we have the electrical for the chassis. This actually has the relays and fuses that control the functions for the chassis itself. Continuing with the electrical for the gale force and the A-force storm, as mentioned, the 80 amp breaker that is mounted on the back of the battery box produces 12 volts and powers up the console for the sweeper. So therefore, if there is no power to the sweeper, or for that matter to the console, therefore it's either the breaker that is tripped, or for that matter it could be a break on the power going to the console itself. On the hydraulic tank, we have two sensors. One is a temperature sensor for the hydraulic temperature, and the other one is for the hydraulic level. So anytime, of course, that there is any kind of back pressure or any kind of restriction on the hydraulic oil to circulate, eventually the temperature is actually going to go up. If that is the case, the sensor right here, of course, is going to detect the temperature going up, and of course it's going to shut down all the hydraulics. Now, it is of course a possibility that this sensor may go bad. If the sensor goes bad, even though the oil temperature is not that high, it's actually going to shut down the hydraulics. At that point, of course, that sensor will have to be replaced. At the same time, in the back here, we have a hydraulic level sensor. So if at some point or time the hydraulic level gets below that sensor, it will trigger the sensor to detect the hydraulic oil being low, and then of course it's going to shut down the hydraulics again. Now, it is of course a possibility that that sensor is actually not working correctly, so therefore it might have to be replaced. The level sensor is the same sensor as we have on the water tank. It's the same sensor, so therefore both of them are the same part number. This is the console for the gale force, and what we see here, of course, is the ignition switch to start and shut down the auxiliary engine. The first row of switches will be the water system. This is your pump, and these are the options for the water system here. The middle row, we have the left gutter broom light, right gutter broom light, the beacon. This is the 12-volt pump that activates the pump that is the emergency pump that activates the hydraulics to use in case that the auxiliary engine is not starting. The next switch will be to go up and down with a hopper to dump the debris, and the one at the end, it is the hopper shaker in case any of the debris is actually stuck at the bottom of the hopper. At the bottom row, we have the left gutter broom tilt, the left gutter broom operation down and up. The next one is the sweeping head up and down. We have the lift bleeder open and close. We have the right gutter broom on and off, and of course the right gutter broom tilt. We're going to go over individually and start those, and I can show the operation at any time that is actually going to be activated. Broom down, sweeping head down. You have to hold the switch until the sweeping head is all the way down to the ground. Right broom down. Now at any time, of course, tilt back on the left broom, tilt down on the right broom, tilt back, left gutter broom light, right gutter broom light, beacon on, and of course this is a 12-volt pump. All you have to do here, of course, is hold the pump on and hold the function at the same time to energize the function. Hopper up, hopper down, hopper shaker, always remember to hold the hopper shaker about 5 seconds, stop, and then repeat. Water pump on, spray bar, hopper water. The screen here, of course, it does show you certain alarms. This is one alarm telling the operator that the water system is low, so therefore he will have to fill up the water tank again. Continuing with the electrical part of the Gale Force, we're going to open up the console so I can elaborate a little bit on the relays and the wiring that it's in the console itself. Okay, so the console cover is off, and the first thing that we are going to point is the individual breakers that are in the front of the console. Starting at the end here, of course, we have the ignition breaker. Then we got the hydraulics breaker right next to it, and then the lights. We have the right across, we have the actuator breaker, the beacons, the water system, and then of course the water pump is at the end of the on the left hand side. Now inside the console we have a what we call the main relay. It is a 75 amp relay, and that one is getting power directly from the battery through this 6 gauge cable right here. This is coming directly from the 80 amp breaker that it's mounted on the battery box, and from here of course we have a direct connection with this wire right here going to the ignition breaker at the end on the right side breaker stash. Now again, from there of course we have another cable here from this post that goes and powers up the lights and the hydraulics. And then there's another one here that powers up the actuators, and then of course there's a jumper going from breaker to power up the rest of the breaker line. Now again, this is a 75 amp power relay, and also it is a continuous duty relay that it's powering that up. We also have another continuous duty relay right over here, and this is for the water pump. That is for the water system. The next relay that we'll see in the console is the low water switch. So anytime, of course, your water on the water system gets low, this relay here will actually shut down the water pump so it doesn't get damaged. This relay, it is the engine shutdown. This relay detects any kind of problem with the engine, like for instance a low engine oil pressure or a high temp, and this relay here will shut the engine down so it doesn't get any further damage. Another relay that we'll find here, it is another continuous duty solenoid, another continuous duty relay that is actually powering up the hopper shaker, and this one is the same, it has the same function as the other continuous duty solenoids. Now anytime, of course, that you have a short in the system, in the electrical system in here, the breakers on the outside of the console will actually pop out. At that point, that function, of course, is going to stop functioning. You can actually reset the breaker by pushing it in. You can push the breaker back in to reconnect and start using the function again. However, if the breaker pops back out, that means that there's a short in that particular setup, and it needs to be found and rectified. In the back side of the front panel, this is the monitor that actually gives the operator, or the technician for that matter, to do certain troubleshooting, or it actually shows the operator or the mechanic if there's any codes or any troubles that the auxiliary engine has at that particular time. So in the back of it, you can see here, these are the plugs coming directly from the ECM of the engine, and actually telling the operator what kind of RPMs is running, if there's any problems with the engine oil pressure, temperature, and if there are any codes or any warnings that the engine sends out for troubles. Okay. From time to time, if you open up the console on the inside, you probably see wires like this. These are terminating wires that actually they are different functions or options that they are not called for the sweepers, so therefore they are actually terminated and they are not hooked up to any kind of switches. On the top of the console, we do have a fuel gauge, and that fuel gauge is only there whenever you have a gas powered chassis and diesel powered auxiliary engine. That particular fuel gauge, it shows you how much fuel you have for the auxiliary engine. The console here is actually the center of your electrical system. Now, every wire that there is here, and of course from here all the way to the back of the unit, every wire is actually labeled, and the label on the wire is actually laser printed, so therefore is not going to fade out. And the label on each wire every 4 to 5 inches actually shows the function of that wire. So therefore you can actually look at the wire and find out what the function is and follow it all the way from the console to the back of the unit. the hydraulic manifold for a gale force and an A4 storm. So what we have here is we have the right gutter broom, we have the left gutter broom. The right gutter broom consists of the directional valve that actually gets the broom up and down. And of course, at the same time, you have a lock valve that locks the hydraulics to the up position so the broom will not drift on its own. And then, of course, we have the three-way valve here that activates the broom to turn and, of course, to lift. Same thing with the left gutter broom here. And then, of course, we have the sweeping head. We have the hopper. And then this one over here is an extra directional valve that powers up a high-pressure water pump if that sweeper it is equipped with. Now, what happens here, of course, is we have a pressure line straight from the pump of the main pump that is mounted on the engine itself, that it comes up here and pressurizes the manifold. In the back over here, of course, we have the return line that goes directly through the filter and back into the pump, and that's how it circulates the fluid. Now, from time to time, of course, if during the transportation on the sweeper, if the broom actually drifts down on its own, it is a possibility that the lock valve, it is either faulty or is actually powering up. Anytime that the lock valve powers up is actually going to allow the broom to drop. Anytime that lock valve is not sealing or is not closing all the way, it will allow the broom to fall. The other problem that it could be at that situation is that the cylinder, the lift cylinder, is probably going to have a bad seal on the inside. If that is the case, it will allow the oil to seep through and allow the broom to drift to the ground. Now, if that is so, in the back of the cylinder, there is a plug, but it is not a plug, it is actually a vent. So if there's any leak inside the cylinder, there's going to be oil on the back of the cylinder, on the bottom end of the cylinder through that vent. That is an indication that that cylinder needs to be replaced. Another situation is if the broom will not turn or it will not lift. The three-way valve, it is a possibility that is bad. Now, the only thing that it will happen at that point is that the broom is actually just going to drop to the ground. That's it. After that, nothing else will happen. Now, the directional valve, on the other hand, it powers up one side and then the other side. Every time that you power up any valve on this manifold, the light, a red light, will come on to indicate that there's power going to the valve. If there is no light going to that valve will not operate. So therefore, at that point, you need to go back and find out where the power is actually broke down. Now, on each one of the directional valves, at the end of the valve, there is a little pin. That little pin is what we call the manual override. So therefore, if for some reason you have a function that is not working, example, the head is not going up, or the head is not going down, or the hopper is not doing that. Therefore, what you can do, you can actually start your engine and push the pin all the way in. In that case, if you have a hydraulic issue, it will still not operate. But if you do have an electrical issue, the manual override will allow the function to work. The hydraulic manifold harness, everything that you need for the hydraulics is actually one loom that it comes around and it plugs right underneath the hydraulic manifold right here. Anytime, of course, that there is any corrosion or any pins that they might be pushed away, you will have a problem here. Then you have to come down and loosen up the Deutsch plug right below the manifold and inspect to make sure you don't have any corrosion or you don't have any pins that are actually collapsed inside the Deutsch plug. The bigger sweepers, A7s, A8s, and A9s, they do have a variable speed brooms. Now on the A4 and the Gale Force, of course, the brooms are actually not controlled by proportional valves. So therefore, the higher the RPMs on the engine, the faster the broom will run. The lower the RPMs, the slower the broom will run. Now, as far as the broom goes, of course, whenever you run the broom down, on the A-force and the Gale Force, you have only a single spring that controls the broom coming out and, of course, the down pressure of the broom. Now, as far as the down pressure of the broom goes, the tighter the spring is, the less down pressure you have on the broom to the ground. So therefore, it's actually going to be minimizing the wear of the broom. On the broom strike patterns, the optimum performance on the broom, or the actual optimum cleanup for the brooms on the A4 and the Gale Force, you can see this is the left gutter broom. The gutter broom is supposed to start striking on the left-hand side at 9 o'clock, as you can see here, and release at 1 o'clock on the inside. That is actually going to transfer the debris from the curb or from the side of the road beyond the path of the sweeping head. Same thing on the right-hand side. The broom on this case, of course, is going to start, as you can see here, at 3 o'clock and is going to release at 11 o'clock on the inside. So therefore, if you're cleaning up the curb, it's going to clean up the curb and move the debris into the path of the sweeping head, which of course it comes into a 12 o'clock setting. At least one time a week, the operator or the maintenance personnel, they need to make sure that the sweeper is set up for optimum performance. So therefore, the curb brooms are going to have the correct strike pattern, as we spoke before about it, and of course the rear of the sweeping head and the side plates, they need to be sealing on the ground all the way. Now again, when the sweeping head is it's all the way to the ground, you need to make sure that the rear seal, the rear flap, is actually sealing all the way across on the back of the sweeping head.